The term net to gross refers to the ratio of a specific portion as compared to a total amount. It's an important factor during reservoir modeling and for making volume calculations. But the exact definition of net to gross is often ambiguous and subjective, dependent on what you mean by gross and what you mean by net. For example, the net portion can refer to net sand, net reservoir, net thickness, net pore volume, etc. Then there's also the question of how are the cutoffs defined when deriving net versus non-net? Are they controlled by geological characteristics, technical aspects, or economic considerations? Do the controls and cutoffs persist across scales of measurements, from core to log to reservoir scale? At the seismic scale, and specifically in the context of spectral inversion layering, we often consider net to gross as the travel time spent in the reflective target material as compared to the travel time spent in the overall gross package. In 3D, the distribution of reflective material provides insight regarding architecture, heterogeneity, and connectivity. To illustrate the importance of distribution, let's take a look at some very simple cartoon examples. To start with, here is a set of strips that shows an interspersed form of net to gross, ranging from 10 to 90%, where black represents 0% and white represents 100%. The same net to gross values can just as easily be represented by a layered system. These strips once again show 10 to 90% net to gross from left to right, but this time distributed using a simple layered form. Same net to gross, very different consequences. Now let's look at an example where the net to gross remains consistent at 50%, but the distribution of reflective material varies. As you can see, distribution bears major implications regarding connectivity and flow. Whenever the concept of net to gross enters a workflow, take the time to have a conversation within the team about specifics. Talk through what net versus non-net means to you, how the measurements that you are working with, be they core, log, seismic, or engineering related, respond to the components that make up the target material, and how the net to gross is distributed, and how the distribution affects flow and storage unit behavior.